And I've heard of a Raspberry Pi. Works well. Cheap too.
Lance Wilpers, software engineering for 30 years. I've got 2 Raspberry Pis, I've got 1 monitor and a full stuff.
Nice.
Pings my phone when it overheats.
Brian, programmer for about 2 decades now. Got 2 Raspberry Pis, Pis as well.
Nate, I have 2 Pis, but I don't really do anything with them yet.
Maybe we can change that.
Alex used to play with Pies all the time. Kind of got bored.
Kyle, I never owned a Pi.
I build likewise.
All right.
Paulo, and I just have it for like a small app setup at home. Yeah.
Victoria, I actually won a Raspberry Pi at one of these meetings.
Nice. Free pie. Free pie is the best pie.
I have 2 Pis I haven't bothered doing with yet.
I don't have any.
Dan, haven't really played with a Pi yet.
I have Amy. I haven't played with one yet, but I'm thinking about playing with one.
All right.
I'm Chris, and my summer project is to build an NTP clock with Raspberry Pi.
Nice.
I'm trying to get Stratum 0 because Cerberus.
Go ahead.
I'm open, I don't have any experience.
Austin, I don't have much either.
Okay.
A couple of Pis. I don't use too much.
Scott, I thought there would be Pi.
Yeah. Darn. Well, giant raspberry. It's right here. Yeah. I don't know if you want to eat it though.
I'm Justin. Yeah, I have one. I set up a retro Pi on it to play Nintendo. And
Nice. All right. Okay, so that is this is my Pi. This used to be car Pi for trips, so my kids could watch their videos and stuff while we were driving down the road. And I just recently converted it last week into the demo Pi, which I'm going to use tonight. So let's get started. The many faces of the Raspberry Pi. Forgive me, I have to put my glasses on. What is it? It's a small, affordable computer you can use to learn programming. It's a small, affordable Linux desktop. It's a small, low-power media server. And it's a small, low-power media center. So it can do both serve and receive. Where can you go to get all that stuff? I have a few links here. I'll put the slides into CPLUG. Of course, raspberrypi.org, raspbian.org, which is one of the operating systems we're going to be using tonight for the first 2 demos. I believe I'm using Stretch. Libra Elect, which is a just enough Linux to run Kodi version of the Media Center for the Pi. OpenELEC, which is another thing like Libra Elect. And OSMC TV, which really never took off because it's kind of its own thing, but it can also receive media from a UPnP server or a Samba share or an FS share. Okay, what is it? Well, there's several versions of it. The first it was a Model A, and I have like 5 of these. 700 megahertz single core CPU, half a gig of RAM. They work pretty good for media centers, but that's about it. You can put a desktop on it, but it's kind of kludgy. Model B, version 2 and version 3. This is a B version 2, which we're going to be using tonight. This has a quad core 900 megahertz CPU and a gig of RAM on it. The version 3 is the beefed up, better version with a 1.2 gigahertz 4-core CPU and the same gig of RAM. And there's lots of other different variants. There's little mini cards now. I figure I wouldn't bore you with all those little things. My demo will be using the Model B2. Where can you get one? Just about anywhere. Amazon has them. Adafruit has entire kits to get you started up to do things like this gentleman over here is doing, where you can monitor things in your house, little kits and one-wire boards and good things like that. And of course, eBay. If you can't find a price anywhere else that you don't like, eBay usually has it. The Pi itself is generally fairly inexpensive. You can get Model A's now for like $19.99. The B's and the 2s and 3s are going between $30 and $45. You get whole kits like this would be what would compromise with a kit. It has a case, a fan inside, heat sinks for all the CPUs, and it came with a power supply, a 2-amp power supply, and that was, I believe, to buy this, I priced it would be like $70 to get everything. And the kit, like I said, would include the SD card to boot the operating system, the case, and power supply. So what do you need to use it? Obviously, you need a Raspberry Pi. I'm using that. To start this demo, you need an SD or micro SD card. Usually the Pi 2 and 3 use micro SD, which is the Wii one, but they come in a pack with the big one. So if you have an older Pi, you can use the same card for it. Minimum is a 4 gig for Raspbian. They recommend 6 gig, and you can take it. I've only taken it as far as 64 gig on one of my Pi 2s at home. You need a micro USB cable, which generally comes with it, and some type of power supply, which could be from your old phone, or you could buy a dedicated one. 1 amp to 2.5 amps. The one I have is a 2.5 amp because it's going to be doing quite a bit. As you can see, all these little USB interfaces in here is going to be running, plus a 3 terabyte hard drive here in a minute. HDMI video display by default, but you can get these cool little things that converts it to VGA or whatever format you like. I'll be using this later to put it up on the screen to show you what we're looking at. You obviously need something to view it on. And if you want to listen to it without HDMI, in other words, you use the VGA output, you can plug a set of headphones or computer speakers into it to listen to the sound that comes off of it. This first example we're going to use is a Raspberry Pi 2. I have a 16 gig SD card in here. We're going to need a form to get the internet. I'm going to be using my phone with the Wi-Fi adapter. HDMI, we're going to go to VGA obviously for here. I brought along a USB, handy little Logitech all-in-one for the desktop person. Put that out here for now. And we'll go to that now, I guess. So let's go through the rest of the slides. The first example is going to be a desktop. I'll show you what it looks like here in a second. The second example is going to be using the desktop image, but we won't go to headless mode. But as a headless mode, as a Plex media server, so you can organize and stream all your media in your home to other devices, Xboxes, Apple TVs, Fire TVs, all the good stuff. We'll make this a media server, and I'll show you how that works. And the third example is going to be a media center using Kodi. We're going to be using Libra Elect, but if time permits, I can show you how quickly you can get that set up. So let's do it. I'm going to unplug this and plug this in. And my handy adapter. And I'm going to steal you. I have a external hard drive enclosure. I think I got it off of Amazon for like 10 bucks. It's USB 3 and has its own power. If you're going to use it, I can get it up in the air here. If you are going to use it, I recommend getting one that has its own independent power because the Pi is not very powerful to go over USB bus, especially if you got all the other things I got hooked up to it. And I've never used it for that. I know when you install Plex Media Server, it installs ReadyNAS by default, so you could technically use it for that purpose. I haven't tried it though. My NAS at home is extensive. I've never needed it. Okay, so here we're booting up. I'm going to turn on my handy dandy little keyboard and mouse combination. And you see what we have is a full Linux desktop, right? We got a nice pretty background. It should be connected to my internet already. I did a lot of this last night so you guys wouldn't have to sit through it. So here's what we have is a basic Linux desktop. And we have the terminal, which I made large so you can see what see the text from the faraway position. It has your terminal, file manager. It can do everything you want to do with a desktop. My kids actually use theirs. They boot 2 different cards. They boot this card when they want to use a Linux desktop on their TVs in their bedroom, and they boot the other card when they want to put Kodi up. But yeah, it's got the full capabilities of it. Just like your desktop, your Windows desktop, your Mac desktop has all the functions and features of a standard desktop. And it runs on this tiny little box, which I can't pick up now because it's all plugged into kinds of stuff. But anyways, does anybody use a Linux desktop at all? I mean, other than, obviously you do. But I mean, like, so just to try it. Any Mac users, Windows users? No, just all Mac and Windows? So this desktop, does it look terribly alien to people who aren't used to using Linux? I mean, it's pretty much, other than this not being down. Anybody want to see anything? It's really not that much to it. It's just very simple.
Synaptic, isn't Synaptic in there too?
Yes. It is the full Debian distribution rolled for the Pi, so all your Synaptic package managers and stuff. I don't think it comes by default. I think you have to install it, but let me start that Plex server up. Oh, I'm already up with sudo. I already got one open. What am I doing that for?
There's definitely a speed difference between the first version and the third version I had. Super Nintendo and Nintendo 64 videos would not play on the version 1 of the Pi. It was just too jumpy.
What do you mean by videos? Like videos on YouTube?
The video of the actual game,
Oh,
sort of
the
like
actual
Zelda, where he's
quality.
running on the horse.
Gotcha.
On the version 1, it couldn't keep up, with an 800 megabyte game.
Yeah, the version 1s were kind of slow. But like I said, for something like Kodi, or even the time that I played with that OSMC product, it was fine because you just tack it to your back-end server and you can see all your media. But as far as YouTube goes, of course I had to go to YouTube after I installed it to make sure it worked. My phone's not the snappiest access point either, but we should be able to see something. We don't know, we wouldn't want to watch Ola England, of course. And yeah. It fires right up. Plays a video. You can play it full screen. I found that the Kodi distribution, the Libra Elect and the OpenX play video better and more versions and formats than the default Raspbian install. So the next phase is I'm going to take this little hard drive over here, which I already have mounted up. Now I'm going to spare you the whole, when you initially set up a Plex media server, it's got to go through and scan all your media. I have about a terabyte on there that I just rsync quick to bring to this meeting. So I'm going to not make you go through all that. Our IP address should be This is the web interface that you get when you first install the Plex Media Server. You can set this up from any browser. Last but 2 weeks, scratched, fingerprints, maybe even lost. I've opened up DVD cases not to find my DVDs. There's DVDs, I don't know where they are anymore. But because I ripped them at least one time, I have them on my computer. That gives me two things. First of all, I don't have to have a DVD player everywhere in the house, or Blu-ray, not like that's not common today, as cheap as they are. All I have to do is have some type of media center and I can stream the video. So when my kids get a Blu-ray, I usually hope that they have the DVD pack with it because Blu-rays are very large even when you compress them. I immediately take it to my laptop or wherever and I rip it and I put it on and I take the DVD and I put it away, and then they can access it from whatever device they're on. They can stream it to Kodi, they can stream it to their Plex apps. So initially last night when I plugged this in, it went through and it tweaked everything and it found all the movies that I have stored on here. And it goes through and it goes out to the internet and it finds all the nice media cover art and all that good stuff and does all that automatically for you. You can see there's some kids' movies in here. And it categorizes them and puts genres on them and everything that it draws from the movie DB. And the TV obviously comes from the TV DB. I don't think I have any kids' TV shows on here because they mostly just watch movies or Hulu. All of my TV shows are going to be probably adult-oriented, something that my kids wouldn't understand, except my daughter does kind of like Rick and Morty, but I don't think she should be watching it. But I have, obviously, The Sopranos and Westworld. Anybody seen any of these movie series, they know they're not for children. But it also goes out and finds the like a generic cover art that only has one season. Let's go to The Walking Dead. And it goes out and it breaks it down by season. Categorizes it by the number of episodes in it. It does all the stuff automatically. As soon as you tell it where to find your media, it just goes to work.
It also tracks like what you watched, what you didn't watch.
Like that first screen when I come up on there too, you see that the last time I used this drive was last night. I was testing my Amazon Fire tablet. I was watching Heart of the Sea. And it knows where I left off. So I could technically, from here, I don't know how well it's going to play on the Pi itself, but you could just jump right in and click play and watch it on this as well. Yeah, resume playback. Does a nice little fan art thing in the background. It's actually pretty cool software for something that you don't really pay money for.
What are you using to rip your DVD?
I use Handbrake. Let's see, it's not playing too bad there. Now we're also in a window. If we maximize it to full screen, which it'll do on any browser, any laptop, anything you have in the house, it's going to struggle a little bit. There we go. But now what this is doing, okay, there's a lot going on here. It's not just taking that video and streaming it at its size to this thing here. It's actually transcoding it on the fly with this tiny little computer. And it doesn't do a terrible job. I mean, it's a little stuttery here, but I'll bring up one of my devices and show you. But yeah, once you, go ahead.
So this is also a version 2.
Yes.
The version 3.
Version 3 will be much faster probably, yeah. Okay, so let's go on to the next phase.
Obviously, it's not streaming from online.
No, it's streaming from this little hard drive in this little box over here. So it's not going through the internet. It is taking those files. Now, I do rip mine probably at a lesser quality than most people do. I like to keep my movies down to like a gig a piece. Some people rip them at like the full flat out 5 gigs or whatever. I don't do that. I mean, I have 14 terabytes of disk space in my media center at home, but I'm nowhere near touching it. But just for the fact of not having to rip it, and when you rip it and it goes through second and third and fourth passes, it just takes forever.
Seth, how do you access that data from other devices? Does the Plex company offer you a way to get to this?
Yes.
Username and password?
Right now it's just set up to be inside in this network that I built here. But there is a check, you know, Matflix. You could check a box and expose it to the internet. Now that gives you 2 options. You can expose it to the world, like they do in Europe, or you could do like Matt does for us and just gives us an email link that lets you access his server. And then it turns on switches and it opens you up to the outside world. In my house, I don't do that. Everything's inside.
But you can stream any devices you have.
Yes.
You've got a Plex app, the iPhone.
Here I have my standard stock Amazon Fire 10 HD or whatever, and I've downloaded the Plex app on it. Yep. I'm going to fire up my Plex app. Now, the key to this is when you have it inside your house, obviously you're going to have to be on the same network. No, I'll rate you later. Thank you. Keep it in mind, we're still doing this from a Raspberry Pi. We don't have some beefy giant box sucking up all kinds of power in the basement. This is coming off of a credit card-sized computer. The name of the server is called Piplex. Yep, you see over here where Piplex is in the top right corner. If I drop down right now, I could actually go to Matflix because I have him in my account. And you're presented with pretty much the same interface as you are with the web browser on the application. Resume. Pass it around and look when it starts playing. I know where all of you live. I can also, while that's going on, stream it to my phone, my laptop, whatever I want. I think the maximum streams I've had on the Pi is 5, and then it gets a little jittery. So, but yeah, you can see you can't really see it. I wish there was more cord and more plugs in here, but you see the blue light flashing on this. Can anybody see that? That's the Wi-Fi adapter. I'm not even plugged into an Ethernet cord. That's another thing too. We're using a wireless network over my phone. Okay, if you were plugged in directly to a hard wire like the Pis have, the stream quality is much faster and much better. I'm pulling it through the air off of my phone, so it's just barely making it. But at any rate, like I said, I'm not sure the limitations of the free Plex account. I know you buy the apps, but as long as you have your internal media server, I don't think there's a limit as to how many devices you can have hooked up to it. Now, you do have to buy the app for every Android device or iPhone device or iDevice, unless you're a lifetime member, at which point the app becomes free. So that's nice about that. And I have 3 kids, and they all have tablets and laptops and Kodi boxes with Raspberry Pi, and they can access this media just the same as if they were plugging it in directly. Now, the Kodi demo I'm going to do here in a minute is actually using the files locally on the Pi. I'm not going to hook it up to the UPnP server, obviously, because I got to eject that card and put in a new card to boot the Kodi up. But, so you see, with just a little bit of hardware and some old 1 terabyte hard drives you got laying around, you could pretty much set up your own media server in the house, and like every DVD you own, you can use Handbrake. Well, I don't think I've ever had a DVD I couldn't rip. But again, and I'm saying this into the microphone, that may or may not be legal or looked highly upon in the United States. But if I own it, I'll be damned if I'm not going to have it on my media center. I have it. If they want to come to my house and say, what movies do you have? And I can pull out my whole DVD collection, say, every movie that's on here is here. I did not go to Redbox, which you can do, and I know people who do, and rip that to your computer and then take the rental back. I mean, we don't do that. We do it legally at my house, even though I live in the sticks and no one will ever find me. But still, anytime you put yourself on the internet, you expose yourself to the FBI saying, he's got an awful lot of media there. I wonder if he owns those DVDs. And then they come knocking on your door, and you know what that is, right? 5 years in prison, up to $250,000 a title. So that can get expensive quick. And by the way, to set this up, the links again are going to be in the presentation. After I had the Raspbian Stretch install on the card, I had to add 1 external repository, do an apt-get update, apt-get upgrade, and then an apt-get install Plex media server, and it was done. That's the only thing I had to do to it. It does recommend you go in and give it a name, otherwise it just says Plex. So and it tells you in the instructions, just go edit this 1 file, and I called it PyPlex. Everything else is set up for you automatically. As soon as you tell it where the media is, either locally or somewhere else on your network, it will go out and download all the data. The Plex server I have at home is pages and pages of movies. This is just a small, what I could rsync in 20 minutes earlier last week. Okay. So that's phase 2. Phase 1 was a desktop that everybody can use. Phase 2 is a desktop, and in this case, also a media server that everybody can use. And this is all freeware, like I said. Nothing I paid for other than my lifetime subscription to Plex, and that is not required.
What was that, like $5?
No, my lifetime?
Oh, the lifetime.
The lifetime was $74.99.
Pretty sure the price has gone up in
Yeah.
recent years.
Plex has been real popular, especially now that you can plug in an HD home run offline over-the-air tuner and record TV right on your Plex server too. So it does a lot more than it did when I first got involved.
It's still $5 a month or like $70.
Is it?
So like you need to pay in order to use it?
No.
What do you get?
Okay, now when you download the app from an app store, I saw this when I initially started working it. It only lets you play like a minute of the movie, unless you pay the $5 for the app. Once you do that, though, on your Plex server, this was before I had my lifetime account, I could watch anything I wanted as long as I paid for the app. Now you can watch it unlimited on a browser. Obviously, you don't need to buy an app. You can put up Firefox, whatever browser you prefer on your Windows, Mac, or whatever, and watch the movies in full screen like we did here. But now that the app exists, like on smart TVs, like I said, the app's on my Amazon Fire TV at home. It's on my tablet. It's on my daughter's got one of them TVs. It's got Hulu and everything built into it. It's on there. So, yeah, Chromecast has it now. Okay. All right.
The loan for 40 yearly, loan time's now 120.
No, so it went up. But, yeah. But you spend, I mean.
It's for the app. I mean, you can use the browser.
Yeah, browser's free.
Also, this is probably 8 months, a year old, but I used to, if I had, I was running a Plex server and I used the Plex app on my phone, which you don't have to pay to download, you have to sign into, but I could Chromecast. It only lets you watch a minute on the phone. So if you're Chromecasting it, it'll play the whole thing.
Oh, nice. Yeah.
So.
Well, Plex actually has a, I've never tried it. They actually have a Raspberry Pi bootable app too. Like you flash the card with the Plex image and it just boots up a Plex Media viewer. I also noticed, like in Kodi now, on my Fire TV at home, if you go down to look under programs, it shows all your Android programs, and I can actually pull the Plex app up from inside Kodi. But with Kodi, okay, here we're not talking about a different thing. You could have the same media server running. It's running a UPLNP server, or whatever, in the background. You can tack Kodi right onto it. You don't need to do any extra. You just tell it where to point, and it gets the media for you. Okay, so I'm going to turn this off now, and then I'm going to turn off the Pi. I'm going to boot up a Kodi micro SD card. And you know you're not supposed to do this, but I'm going to do it. I'm going to turn it right off, just for time. If you do that with Kodi, it yells at you the next time you turn it back on. You didn't shut down Kodi correctly. And I got this little 16 gig, everybody knows what a micro SD card is. I'll pop that into the back of this. I'm going to turn it back on. Now I'm going to switch controllers, because I like this one. This is perfect for a media center. I'm going to turn this off. Again, I got that. This is Amazon for, I think, 14 bucks. The cool thing about it is it lights up, green, and I like green. So, but it has a touchpad on it. It has the playback controls. It has the controls to go through Kodi. It has a full keyboard, so you can type in your whatever you want to find. This is a Ambo Love T16. I mean, if you do a search for a wireless media center controller, this is like one of the top 3. And like I said, it was I think it was $14.99 actually. There. Now I went through last night and I scanned all this in so you guys wouldn't have to sit through it. But this is seeing the same hard drive that the Plex server was seeing, obviously, because it's still plugged in. And you see it kind of does the same thing. Has anybody here used Kodi before? Okay. Back when it was XBMC, yeah. So this is what they would call legal Kodi. This is you using your local media to go out and, my terabytes at home, it just scans it the same principle as it did with the Plex media server. It just goes through the list and does a little better. I mean, this is one skin. Kodi has many skins, many ways to look at it. But again, it's free, and this image takes even less time to install on an SD card. This is Libra Elec. They actually have a graphical installer for the DD challenged, because I remember back in the day you had a DD if of and write it to your SD card. Now they have a graphical installer that actually goes out, downloads what version you want, writes it to your media card, and then lets you write more. That's how I mass produce cards. I can burn off 4 or 5 of them in a row with that software on the Mac. But I actually think the playback when you use Kodi is a lot smoother. Obviously, it starts to load up. Over HDMI, it is 5.1. All my videos are. It's kind of jittery. Not sure why that is, but the playback is much better and much faster. Obviously, because Libra Elec is just like it says, just enough OS to run Kodi. So there's not a lot of bloat in the background. It's pretty much what you need to make the video come up on the screen and the audio, and that's it. A graphical interface. But pull it up. It's got lots of cool things you can do with menus. You can change the size, change the sound, turn on subtitles, all kinds of great stuff you can do with this. And if it doesn't have the subtitles, it'll go out and find them for you and download them. So if you want to watch an English movie in German, it'll put German subtitles up on the screen for you. I don't have any audio, so this is kind of lame, but anyways. You see that it plays full screen, no problem. Just off the same Raspberry Pi, using the Kodi image. You can go back through them while that movie's playing. You can start another movie. You see as you go through the list here. It takes a little second or two to catch up, but it does have all the art stuff downloaded in the background. And if you're a Brat Pack fan like me, you got all the original movies with Molly Ringwald and all the other guys in it. And you see it just started right over top of the other one. It didn't make you stop. It didn't make you go back. It just started. So, anyways.
How is Kodi different than Plex? Can you serve this up to the internet?
You can serve it up in your house. If you found the port, like this, Kodi distributions have a Samba server in them and a UPLMP server, which you can turn on and off here. So if I was to kick that on with this hard drive attached to it now in my house, that would broadcast to other devices saying, hey, I got this media, you want to watch it? And you set it up here, or you can use the Samba. If you go into settings, file manager.
So one of the differences is Kodi is an app, like a desk thing, or like a desktop, or like a media player.
Yeah.
So it doesn't actually stream the stuff. So he's talking about Samba is a
process.
File sharing essentially.
Yeah.
So it will you can enable file sharing. Kodi isn't doing that though. That's just Linux serving files in the background. Whereas Plex is both a streaming protocol and like the library, like all the art and stuff. And Kodi will go out and get the art and stuff for you, but Kodi itself isn't like a streaming protocol. You don't have to have a Kodi app or somewhere else to watch these videos. You can just stream over Samba.
And Plex will transcode, which Kodi can't do.
Yeah.
Plex will take a large media file and based on your streamability, reduce or increase the size.
So while they're similar, they're definitely different. Plex is transcoding and actually streaming in its own language, whereas Kodi is essentially just a media player.
It's just a skin over top of the player, I guess.
One thing that wasn't mentioned though is Plex also contains network tuners, so if you want to record off the air or off the cable.
Plex can, well, both Plex and Kodi now can use the HD home run tuners, and you can record on them and set up. And I don't know if it does. Yeah, I don't know if it does the whole cool thing like Myth TV used to do, where you can cut out the commercials, but it will record the video. Yeah, I have an HD home run, and when I plug it in, Kodi can see it. One of those HD external tuners.
That's not just for live play, that's for it is.
Well, it will stream, but with a recording software, I can record off of it as well.
Can you watch broadcast stations like the local ones, like Channel 8 and Channel 4?
If you had what we were talking about, you have one of these off-air tuners. Like I have it's a network-based tuner. You plug it into the Ethernet port, and it has 2 ports in the back that you hook antennas up to, and then it streams that data to whatever device can read it.
What's it called?
HD home run. Yeah, silicon dust. Yeah. Now, obviously, I'm going to go back out of here and back onto here. Again, to use these things, let's see if I have the app here yet. Yeah, there it is. Here's the LibreElect installer. Now this is the Mac version, but the Windows version I assume looks pretty similar. You can go up to select the version, pick what version of the Pi you have, pick which release you want, and then download it. And then once you get it downloaded your, if you have an SD card like I did, this shows up here, and then you just click burn, and it actually just burns it. So once you download it once, like I did with this, I can replicate it as many times as I want to put cards in. It's real simple and easy. Back when you first started, you DD'd the file over. I mean, if anybody uses Linux, they know what DD is, DD if of dev, and then this actually gives you a nice little graphical thing, shows you progress meter, all that cool stuff. And
select version. Is this only for Raspberry Pis, or is this for
this?
Like you do like a x86 computer off this?
Yes.
Okay.
There's all the different variants you can download.
Okay.
Generic AMD right there, yeah. Then you choose the version. Right now there's only one version being offered, but I guess you can click show all. There you go. So if you don't want the latest Kodi, you can go back. I don't know why you want to do that. Now the other thing about the Kodi boxes too is with LibreLec and OpenLec both, if you check the box in the thing that says automatically update, it'll download the updates when they come out, and then the next time you reboot it will apply them just like an inline patch. So once you get it installed, it pretty much keeps itself up to date. But the installer is dead simple. And that's really all I have. It wasn't supposed to be a fantastic talk. Just everybody, you know, the Raspberry Pi goes by the way, and there's way more things you can do with it. If you go to raspberrypi.org, there are so many projects. There's a guy who's making ROVs, like swimming in the trenches off the coast of Florida, running off of Raspberry Pi. This is the very basic, what I use at my house stuff. There's way more advanced things you can do with them.
We're going to go ahead and take a 10-minute break. We've got pizza here. Thanks again to Tech Systems for the pizza. And enjoy it. We'll be back in a bit.
you doing, bud? Hey, this is last month.
Cincinnati sequel event, sequel Saturday.
Oh, really?
Cincinnati, so I took the whole team
I can take that
of Ohio out to it, so.
That's probably my least enjoyable thing. Yeah. I guess I should look at sequels.
Well, it all depends on what you do. I don't think we do any apps at all that don't talk to a database.
Yeah. Yeah.
And with my job on DevOps, I pretty much play with everything from deployments to TFS to source code control systems I manage, websites, databases.
Yeah.
The nice part now is we're actually doing database projects where they're actually doing everything and all the source code, all the T-SQL and SQL and views and the tables are all in the source code. The whole thing is in the source code. And I can click deploy and I can actually push an entire database out to the server.
If it's your branch, yes, yeah, doesn't matter. Yes, dude, you can figure that out. I've been reading about it. Yeah, I've been reading about it.
The only thing we found that didn't work.
Still, you can brag about it. Like, I know what I'm talking about. Oh, I know what I'm talking about. Whatever.
It's a weird thing that has built-in triggers on tables that anytime you change something, it captures exactly what you changed and traps it. DevOps, that's like the nightmare for DevOps people right now, because it doesn't deploy very well. It's a real pain in the butt.
So it doesn't really matter. It's like every time you force push something, it's like force push it anyway. Force on something. It's like when you do like RM -F. Yeah. Like that's scary.
I do it all the time with Docker. It's like, are you sure you want to delete this file? Yes. Are you sure you want to delete this file? Yes. Are you sure you want to delete that F? Yeah, exactly. That's exactly what you do. Dash F. RM. I have an alias. Dash F all the time. Is it? No, it's not. There's we're talking about. Have you here?
The back of one is for you. Cheese.
But then they're like, well, so they know that I like it, right? Nope. And they're like, well, they want to call. They're like, they're making mistakes. There's 14 degrees by all we want. Well, you didn't go all the rice. No, bro, you didn't go all the
All you did is show up.
So,
hey, I helped organize.
Learning.
Oh, you could have just told me where to go.
I did. You just slapped me.
What do you want? I was sitting in the parking lot.
You have a choice between cards. Either one is here?
Yeah, because one I'm doing right now, two times go here, right? And then one,
So I just made 3014.
You're just on security right now, right?
Thank you.
right now I'm doing it from the last meeting. Right now, it's greatly appreciated.
Oh, okay.
I found it back.
I thought you were doing security.
You work with
Yep, it's all right over there.
awesome. I heard you just got a
Yeah, my baby girl.
I'm sorry about not getting back to you about meeting at the cafe.
You got the wrong one. Well, I was asking about that SSD. That was quite the ordeal there. I've shown up for my I've been lazy over the years. And I got what I call a rat feud. Those rat rods you see on TV? Mine's a 10-year-old rat. I just keep, you know.
One day he went on this tangent of regulation of why Ford got sued for, or something like that. Yeah, this whole thing about yeah, but it had nothing to do with this stuff at all. And this went on for like 45 minutes. Like, okay, talk about something different now.
Like, leave your idea with yourself at home. Talk about it on here.
Now, like, we have more than like 6 people sometimes down there. Someone said that there's a WordPress group.
Oh, that's not true. So he goes to WordPress instead of going to that.
But none of the other guys there go either. From 10 metrics of so the Allison, Jason, works on TrueNAS or something like that.
I think still have that great.
Hey, yeah, yeah. I'm currently left. Sorry?
He works with you then. And you're the partner.
Very close.
So be working on that probably. Oh yeah. Oh.
So yeah.
That's a good question. Probably Alex at this point. I'm not pretty, and it's going to be tricky because we don't even have a venue yet. So I'm going to see if we may just do something smaller. Just see that work. Sit up there, just low key, and do something simple.
Yeah, just let me know.
Okay.
If that's what you want to do, and I'll make sure that it goes around
Okay.
there and the internet is right, like it was last time. Little hiccups, but I'm gonna help.
Okay. Well, yeah, let's kind of plan that way because otherwise I don't have, I can't, I'm not
Yeah, I love
going to
it.
use it.
So, no, that's fine, if you're comfortable with us posting it, that's
Okay.
fine, just, I'll make sure to get Alex's number.
Yeah, okay.
Because I don't want to bug you at the beginning, so.
Right, okay, sounds good.
I was talking about the battery.
Simon Lines and stuff like this. And then just the way that so now so I'm not heard that I'm still on the spot for a conference or something, you know, but it's screen and location and everything.
Yeah. Where's your office?
We're located off 39 Progress area. Progress Avenue in Harrisburg.
It's preferable, but I've been on Progress for
Okay. Yeah, if you get off 81, instead of going towards like Susquehanna Shores where my current car is, like more towards the mountains. Or the hills, I guess. That's really mountains. Right. How's your student doing? Yeah, I was wondering, yeah. He told me he was interviewing there because there's some security spots and financial links.
Yeah, that didn't pan out. I forget why. Being a good job.
It's just, it's heads down, like signing yourself to defense, like doing rampage and users, like just meeting people, but I think they're looking at
It's kind of weird how variety of different security stuff. They want to actually have it. They love that.
He sit downtown? He sit It's by one year meetings. They have a lot of admin, but not that admin buildings, but they have a lot of buildings for workers and stuff.
I guess they buy a lot of practices or merge practices with them. And
which I think is, yeah.
Okay, we are going to go ahead and get started with the next segment. So this is Mike Newswanger, and he's going to introduce us to Kubernetes. So Mike, take it away.
Will do. First off, how many of you guys have heard of Kubernetes before? All right, we're off to a good start. Keep your hands up if you used Kubernetes before. All right, we won't even go to the production environment question then. How about containers? Any of you guys use containers, Docker, LXC, any of them? Okay, so a fair amount. All right, so first off, who am I? Mike Newswanger, currently an SRE at Stack Overflow. So basically systems development, combine the two and you got SRE. Previously, I started as a developer at Webstaurant Store, was a database admin there and an SRE manager. You can follow me on Twitter and pretty much any other social media at mnewswanger. So let's start out. What is Kubernetes? Well, if we go to the Kubernetes website, we get a production-grade container orchestration. Great. So what's that even mean? So if you look at the subheading then, automated container deployment, scaling, and management. Now we're getting a little bit more close to the English side of things. So less jargon, and it's starting to make a little more sense, but we got to figure out what those kinds of things are. So let's break that down a little bit. Containers. So quite a few of you guys said you use containers. For anybody that hasn't, a container is effectively an isolated process on a host. It's done through Linux, through namespaces. Effectively, you share the kernel, but you separate all the other resources out. So you'd use C groups, and that's done by the container engine. So it's analogous to virtual machines in many ways, but not exactly, in that you get a lot of separation, but you lose a lot of the overhead. Where virtual machines try to emulate an entire stack of hardware, containers are just simply running a process. And a container is a running instance of an image. So what's an image? A container image provides a couple things. One, it provides a base file system for a container. So that's going to give you stuff like binaries, configuration files, anything else that you want to throw in there in the file system. And it's also going to provide a bunch of metadata. That's going to include stuff like who made the container, what does it run on. So you could run it on ARM, you could run it on x86, information about like that. But it also provides information about what the container does. So the metadata is going to say when you start the container, unless you overload it, this is the process that you should run. That's going to be done through a command and an entry point. So you can specify if you go out, you download a CentOS image as a container, the entry point for that is bash. So if you run the container, by default, it goes into bash. And the container runtime. So I touched on that a little bit, but the container runtime is what actually runs the container image. So the container runtime says, hey, we've got an image, and creates a container from it. Like I said, basically spawns up a process. And it's also responsible for mapping resources. So the container engine is going to do stuff such as volume mounting. It's going to make sure that the resource constraints that you put in place are respected. So if you say this container should only have 200 units of CPU, then it ensures that that takes place. And it ensures the process isolation, like I said, through namespaces in the Linux kernel. So what's all that got to do with Kubernetes? Let's jump back to that subheading again, automated container deployment, scaling, and management. So now we know these containers that we just thought of here are deployed, scaled, and managed by Kubernetes. So let's back up again to how has infrastructure been managed traditionally? Traditional infrastructure. Now this goes way back prior to virtualization. Adding services is directly correlated to adding servers. If you don't want to mix and add multiple servers or services per server, you've got to add more servers. That's the only way you can add new services. So adding servers means now you got to use more space, more power, a lot of cost, and potentially long lead time. You can't just go to the Dell store and say, give me a customized computer and walk out same day. Some of these guys can be weeks or months lead time to do your builds properly. Failed hardware means that services go down, unless you maintain a full stack of spare hardware. And this is pretty much ignoring clustered services, because that adds a lot more complexity. And if you're dealing with clustered services, then it really can solve some of these, but you still have the expense of adding more resources, and clustering on physical hardware means even more resource overhead. So yeah, you've got a long lead time, really expensive. You got physical constraints, and power means heat, so you've got to dissipate that as well. There's a lot of downsides to running very traditional infrastructure. Introduce virtualization. Virtualization revolutionized the world, and everybody in the 2005 to 2015 range said, let's virtualize everything. And yeah, there's a lot of pros from it. Maybe not the best idea to virtualize everything, but hey, overall works great. So adding services now becomes adding virtual servers. So rather than having to get something new, physical, allocate more space, allocate more power, you can do it all through software. So your deployments become software-based, assuming you have the capacity, but you can maintain a lead on capacity. So if you've got a VMware cluster, for example, you make sure that you've got enough that you have some breathing room. If you need to add more, you can add a little bit more in terms of throw another server at your cluster, and then adding more virtual machines basically becomes a software operation from there. Failed hardware, pretty much any clustering hypervisors will mitigate that by moving off virtual resources. So if you run out of some kind of resource, whether you can no longer power the machine, whether disks fail, etc., stuff can move, and fairly transparently to the end user, you're resilient. Lead time becomes hours or days instead of weeks or months. So you reduce that greatly, but containerization takes that a step further. Because you're just spinning up a new process when you bring up a new service, you now have a lead time of seconds to minutes. Failed hardware means you have to migrate the workload. Very similar to virtualization. However, unlike virtualization, the technology isn't nearly as mature, and you don't have as many options in terms of, oh, we'll just bring it from here over to here. And adding servers, once again, maintains the software-based deployment. So you don't have to go into the data center, throw in a new physical server, and do all that. You just say, hey, I want to go run a new container, and you do it. This is where Kubernetes comes in. So Kubernetes effectively provides a management framework for containerized infrastructure. That's my little synopsis of it, which is great because it provides a lot of common tooling. It provides a lot of the functionality that we've kind of come to rely on in terms of virtualized infrastructure for reliability, resiliency, and failing. So it deals with fault tolerance well. And it also gives you a common abstraction layer for pretty much any service. Because if you go to Google Cloud, if you go to AWS, if you go to Azure, if you run it on-prem, if you're running Kubernetes and exposing a native API, you've got the exact same interface no matter where you go, which is huge because in the current state of things, people are looking at more multi-cloud solutions. They're looking at running hybrid between on-prem and in the cloud. And if you start doing that, and you have the same abstraction layer between anything that you run it on, now you don't have to worry about, okay, so our developers need to learn tooling around AWS, they need to learn about GCP, and they need to deal with our on-prem solutions. So because of that, it basically takes and abstracts away a lot of the traditional work that needs to have been done by a sysadmin. So how does it actually work? First off, I'm going to introduce the concept of labels because it's used everywhere in Kubernetes. Labels is very difficult to grasp. It's a key value pair, each being a string. I lied about the difficult to grasp. It's pretty simple. So the key value pairs can be assigned to just about every object in Kubernetes. So when you create an object, you can say, here's a couple of labels that I want it to have. And you can then use those labels for tying things together, for keeping things apart, for separating workloads. For example, if you want to tag nodes, you could say, this node has access to fast storage. So you say fast storage equals true. Now you've got yourself a label, and when you tell something to run, then you can say only run it where fast storage is true, or only run it where extreme compute is high, or whatever you want to do. It's all key values. It's all completely up to you what you want to allocate it as. And labels are indexed. There's also the concept of annotations, which behave very similar to labels, but they're not indexed. The big difference there is you can't filter on annotations. So annotations are great for stuff that comes back with a read operation. Labels are great for stuff that you want to filter objects against. So knowing that, we go to the actual architecture side of things. And we have two main roles in the Kubernetes. We've got server and worker. So in that respect, you can run all the resources on the same server. It's possible to do. Depending on the environment, may or may not be a good idea. But you effectively have two different sets of capabilities. First off, on the server side, we have three main functions. We've got the API server, and the API server does pretty much everything in terms of interaction between components. So if a component says, hey, let me know what's running, or the component says, hey, I'm here, I can do work, all that stuff goes to and from the API server. It's all an HTTP-based REST API, secured with TLS. Everything persists through the API server to etcd. So etcd is where the persistence happens. Only the API server ever talks to it. Also running on the server side, you have the controller manager and the scheduler. And effectively, the jobs of those two are to make sure that Kubernetes knows what should be running, and to make sure that what should be running is actually running. API server can be hot on multiple servers. We've got the worker nodes. Those run two processes. They run the kubelet process and the kube proxy process. The kubelet process effectively interacts between the Kubernetes masters, the servers, and the container engine. So there's a bunch of different container engines that are pluggable. Most common is going to be Docker. It's most stable as of now, in my opinion, and has the most tenure. However, there's a couple up-and-comers that are looking very promising. There's CRI Container D and CRIO, which interact with Container D between Kubernetes and Container D directly, rather than going Kubernetes to Docker to Container D. So it takes out a little bit of the shim layers. And there's CRIO, which effectively goes between Kubernetes and your container runtime, which would, in most cases, be run C at this point. So the kubelet says, Kubernetes wants me to run this container or service, and makes it happen. That's its job. The kube proxy then proxies services within the Kubernetes infrastructure between external in and internal out. So if you have a container that wants to access a service in Kubernetes, and I'll get into what a service is in a bit, but the kube proxy handles that in and out pattern. By default, assuming you have IP tables installed, it'll use IP tables to do all the manipulation. So that gives us a high-level overview of the architecture. So let's take a look at logical components. And this is where things actually start to happen in Kubernetes. First off, we've got the concept of a pod. A pod is a set of one or more containers. Pods share an IP namespace, aka single IP address. Ports can be exposed via different containers. So if you have 3 different containers running in a pod, you could expose 80 on one, 22 on another, and 443 on a third. Each of those gets mapped, and you can address any of them via that single IP address. It also supports the concept of initialization containers for startup. So what that means is you have your set of containers that are designed to be long-running for the service, and if you want to have something like run a DB migration prior to starting to serve traffic, you can create an init container that has that payload in it. That does the work, and when that finishes up, it brings everything else up. So that's handy for rolling different deployments and upgrades. But the concept of the pod is effectively a group of one or more containers. That's the takeaway there. creating pods, typically you wouldn't do directly through the API. Pods should be created through another object in almost every case. So pods can be created by deployments, stateful sets, daemon sets, jobs, scheduled jobs, replica controllers. You've got a whole list of them, but the most common of them are listed here. Deployments are effectively what you'd use for your typical stateless stuff that's going to be long-lived. So if you have a web server that you're trying to run in Kubernetes, a deployment makes sense for that. That's going to let you scale up, scale down, put autoscalers in place if you want, but it's designed to be very flexible. A stateful set is very similar. However, it is designed to be more targeted toward long-running stuff. It gives you more predictable naming on the containers that it creates, where a deployment will create your deployment followed by a hash, followed by 5 random characters, followed by another 5 random characters to tie between the replica set and the deployment. That's completely random. A stateful set's going to allocate by an integer starting at 0 going up. So it's a little bit more predictable if you want to do something like a database cluster, for example. You can still scale it, but it's much more predictable in how it works. Daemon sets are designed to run pods on every node that's in your cluster. So if you run a daemon set, that's going to say we've got 3 different nodes, run 1 instance on each node by default. A job is designed to be effectively the equivalent of a cron job. So if you're familiar with the concept of cron, which I imagine most of you are, that's going to roughly equate to a Kubernetes scheduled job. And a job is going to be similar to like a one-time fire. So there's 2 different jobs there that are defined in the Kubernetes API. And like I said, the behavior is very similar. The scheduled job runs on a designed schedule. But those guys, once again, will create pods underneath. So whenever you create any of these, they all do the pod creation underneath. So that's the link between the 2. Services, yeah.
What would be an example of like a job, like something you would just run once?
Say a build task. Okay. So if you have a CI system that you want to do a code base build, you could do that through a job, just fire a one-time through the API. So yeah, like in your case, if you have a Go app that you want to build out, you make a git push, you receive the git hook and say, hey, we've got a new commit. Now go run the test suite through Kubernetes. That could be a job. A job's going to fire. It's going to live until you delete it. So it'll exit out, but it'll leave the logs there. So that's a really handy thing with that. So you can go back, check, make sure that it completed successfully, and you have a one-time run. Okay. Any other questions on that before I keep going? All right. Services expose stuff. So if you want to run something that's exposed to end users or exposed to other containers, you don't want to have to rely on a pod name that's going to be completely arbitrary, right? You don't want something that's random. You want an anchor point that you can hit that's consistent. That's where services come in. So services can expose effectively a persistent anchor to an ephemeral service. The way that these guys link up is labels. So you can say, my service exposes port 3306 to anything that is application foo and service MySQL. It then says anything that matches those labels can feed this service. So when you hit the service port on 3306, it says, oh, you can go to here or here or here and routes you accordingly. It can be exposed both inside and outside the cluster. So this is useful for external clients reaching in or pods reaching to other pods. So once again, you don't want to anchor to something specific in terms of a pod to another pod. You want to anchor through a service. So pod goes to service, which goes to another pod. And it plays nice with both TCP and UDP. So you can do stuff, DNS being one of the prominent UDP services. You can expose DNS via a service. Persistent volume. So this is how you get persistent storage in Kubernetes. Persistent storage gets bound between a persistent volume to a persistent volume claim to a pod. So you would create a persistent volume definition that says, here's where my physical storage actually lives. The persistent volume then binds to a persistent volume claim that says, I want X amount of storage, and I want it to match these labels. So for something like that, you could do a label such as, is SSD storage, or has high throughput, has high bandwidth, has high I/O, is read-friendly, things like that. However you want to tag it based on what your physical capabilities are on that volume. And then that binds to a persistent volume claim. The pod then says, hey, I want this persistent volume claim, and then can map that in as a volume to the pod. So a little bit tricky to kind of get your head around initially, but once again, everything is done through labels between the units there. So to try to get this a little bit more applicable, let's build an application. So first off, what kind of applications could you run in Kubernetes? Anyone? Web server, okay.
Web services, web APIs.
Yeah, that's a pretty straightforward one. Anything else? What's that? You could, yep.
Can you run any kind of application?
Theoretically. There's some that are more prone to it than others, but hey, just because you can. So, all right, let's go with the web developer idea. And so you're a web developer, you want to build out an application, and oh, this Kubernetes thing is really cool. I want to use it. So how do we do it? First off, what do we need for a web application? We need static content servers, we need dynamic web servers, and we need database servers. So this would be something that we're separating off the dynamic and static payloads. Database servers are going to be your dynamic backend. Yeah. So static content servers. These guys are pretty straightforward. All we got to do here is create a persistent volume. Now, one of the cool things, and there's a ton of information out there, and I have a couple resources linked at the end of the slide deck, but one of the cool things you can do with persistent volume is say, we want a mode of read-only many. That says that any pods can read it, any number of pods can read it, and so we can pass it in. And if we use a persistent volume with read-write many, or sorry, read-only many, that means that one, none of our containers that are running on the front-end services can write stuff, which is good from a security practice. Two, it lets us scale. Assuming our storage backend can support the workload, we can have as many worker nodes as we need just by issuing a scale command. So it gives us a nice, safe layer. Then we can do dynamic web servers, which we can also do through deployment because, once again, we can scale them up and down. It's not really going to hurt anything if we add more web servers or take them away for the most part. We can deploy with the code base shipped in the image. So we can build an image, basically bake the code base to the image, and ship it up. And then we can map secrets as credentials. And secrets are effectively a way to store any kind of information securely. So this is going to encrypt. It lets you mount them as a volume. So effectively, you can create a mount point with the secrets inside of it. And the secrets inside of it can be a string format. They can be a file format. They can mount as a directory, as a single file, etc. So you can then ship your container, and the image is going to have nothing sensitive in it. And then when the image pulls down and Kubernetes runs it, it injects those variables for you. So it gives you a safe way to deploy your application without exposing production secrets to everybody. Yeah, and then database servers make sense for an instance of a stateful set. Once again, we're going to want a persistent volume because containers are ephemeral. If your process goes away, everything else goes away with it. You don't want that. You want your database to stick around. So for that, once again, we want a persistent volume. Now that one probably makes more sense to do a read-write once, which says one container can get read-write access to it, and use a stateful set. So that's going to give it a little bit more predictable rules to follow in terms of the pods that it creates. But once we have all those, now we can expose each of those via services. Really, the static stuff doesn't need a whole lot in terms of services to access anything because it can just kind of operate in its own space. But the dynamic servers are going to need to get back to the database servers, right? So we can create a database service which then links between the pods and the database servers. So your backend can talk to your storage, which is what you want.
So how do these containers talk between each other if they don't have host names, IPs, things like that that is, you know, normal of a virtual machine?
I will get into that in a second. So where can I learn more? Here's a bunch of resources, a lot of official documentation. Kubernetes Up and Running is a great resource to dive in and learn a lot of at least the basics. There's a Slack community, Reddit, their official website, and their Twitter. Yeah, so I'm going to kill the feed here. Can you kill the video? All right.